Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of proportional and non-proportional graphs. This is standard 8.5F in the great state of Texas, and we are using item number 18 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we just need to find the one equation that does not show a proportional relationship between x and y, and we don't even have any graphs. If we want to, we can go ahead and graph these, and we will find one that looks different. But if you know what you're looking for, this is a simple problem, and you've probably already answered it and moved on. So let me show you how you can figure it out by graphing. So let's say you don't really know what that means to have proportional and non-proportional, right? So this is what we're going to do. We're going to kind of decrease the transparency here. Let's just make some simple graphs here, right? And so I'm just going to make some right here, right? And so we'll start with A. Y equals, what is that? X over 12. Okay. So y equals x over 12, and let's see what happens. Let's always start with x equals 0. Okay, so if x equals 0, why then y equals 0? That's going to be 0, 0. Okay, so we're going to start right there at the origin. And then always see what happens if y equals 1, or if x equals 1, well, then y is going to equal 1 over 12. So that's barely going to go up like that. Okay, so now we can kind of plot that very, very shallow slope. Right, so there's my A right there. Let's see what happens with B. We'll do this same thing right here. What happens if x is 0? Right, we've got this y equals minus 15x. Well, if x is 0, y is 0. That's pretty simple. And if y is 1, we're going to get, or if x is 1, excuse me, negative 15. Okay. So let's make that go way down here. Let's just say we're not counting by ones right there. So it's going to be really steep decline. Look at that, negative slope is negative 15. All right, so there's my B. Let's see what happens if I do C right here. All right, so my C is y equals 2/3 x. And if x is 0, then y is going to be 0 once again. All right, looks like we're going through the origin again. And let's see what happens if x is 1, then y is going to be 2/3. Right, so just plot 2 points. Start with x is 0, x is 1. Those are kind of super easy. And so we'll kind of make that go right there. All right, so that's kind of going to look like A. It's going to be a little bit of a more steep slope, but still not much. Okay, so this is your C. All right, so A, B, and C look like they're all going through the origin here. Let's see what happens when we do this D. Got a little room, we'll do it over here. All right, and then D is, oh, it looks a little bit different. It's y equals 7x minus 9. Okay, so if x is 0, that's going to be 0 times 7, 0 minus 9, so that's minus 9. So 0, I'll kind of make that my minus 9. Then if x is 1, that's 7 minus 9, that's minus 2. So that's going to be like up here. Let's say I'm counting by 2's. So if I wanted to draw my graph there, take a look. And visually now, you can see the difference. The difference here is A, B, and C all go through the origin. That means they are proportional. D does not go through the origin, so it is not proportional because it's got a y-intercept. It's in the form of slope-intercept form, y equals mx plus b. When you get something that looks like this, this is going to be not proportional. When you get something that looks like y equals kx, the direct variation, like A, B, and C, those are proportional. So my answer here is D.